So somebody is asking, please explain perceptron. So essentially, the idea is this. I'll quickly go over it. So if you have this kind of a situation, a hyperplane will separate the two. So what is an hyperplane? It's like ax plus by plus cz plus d, right? So that is the equation of a hyperplane. Or I can say abc transpose term plus b. So all that I have to do is w transpose x plus b. So I have to implement that. How do I implement? The implementation is this, right? So x1 times w1 hat plus x2 times w2 hat and so on, xm times w1 hat plus b hat. That gives me the hyperplane equation, right? If I look at the sign of that, that will tell me whether it is to the left or right. Okay, so it's a simple implementation of a hyperplane test. That is what a perceptron is. Okay, so any other questions online, people? Okay, so offline, any questions from people here? No? Yes, fine. Okay, so now I think we will keep revisiting some of these problems again and again over the course, but let's move into the main topic, right? So it's mathematics for data science. It's not data science itself, right? So let's see, suppose I give you a function, right? So minimize for all x f of x. So how do you minimize this function? So suppose the function is like this. This is something that you need, right? I don't need to motivate why one should solve this problem. We know, right? Suppose I have given the data points or the data, you are supposed to learn a neural network, then I have to minimize something, right? Some function. So suppose the function is like this. Now, this function could be very complicated. One way is you take the derivative equated to 0 and figure out the stationary point and all that, right? But suppose this function is very complicated, right? Meaning, if I say take the derivative equated to 0, it's like very complicated, highly nonlinear equation, which is difficult to solve. So how do you solve this problem? Well, easy, right? So what you do is you randomly start at some point. Let me call it as x0. Okay. Now you look at the derivative at this point, right? Okay, the slope, right? If the slope is negative, what you should do? You should move this point to the left, right? Consider a new point x1, right? You'll get this again slope. Slope is negative, you move slightly to the left of x1 and keep on doing that, right? Eventually you hit this point. We will see more in great detail what this algorithm is and all that later on. But essentially what you get is a sequence of points, and if you were to implement this algorithm, the algorithm will keep on iterating, and if it will keep on iterating forever, which is not good, right? You should iterate as less as possible and achieve the best, right? In other words, you should go and reach what is known as, you should converge, right? So that's the right word, right? So it should converge to some point which is good, right? Therefore, we need a lot of calculus here, right? We need what do you mean by limit or the convergence of a sequence? We need to know, for example, these x0, x1, the sequence need not be numbers, right? This could be vectors. So what do you mean by convergence for a vector and so on, right? These are all obvious questions one can ask. Now let's start with the basic, some quick overview of calculus that you would have studied in your first year. I think first year, right? First year or third? I think first year, right? You would have studied these things in the first year. Okay, so let's do a quick review of basic calculus, or you want to call it as real analysis, which will be helpful later on. So I will revisit this again, okay, so for multivariate calculus, but for now, let's look at this. Okay, so suppose I give you a sequence, right? So what is a sequence? Sequence is basically x1, x2, x3, and so on. So by the way, I won't be very rigorous as a mathematician, but if you want to learn more about this, maybe you should read a book on real analysis, which will be it'll be a rigorous treatment. Okay, so you have a sequence, right? x1. Okay, before that, I hope everybody knows what a natural number is. What is rational, irrational, real. Okay, so I'm assuming that. Okay, so suppose I take this sequence, and typically we say, oh, limit of this sequence xn as n goes to infinity is something, right, x star. So what do you mean by that? Can somebody tell me what is the meaning of this? So typically what you do, 1 over n limit n tending to infinity is 0, right? Some intuition you have, you just apply, or if you are really a bad student, then probably, you will apply something, some rules, and then not give the correct answer, or give the correct answer, but you don't know why, right? So can somebody tell me what is the meaning of this? This is very important, right? So without knowing the meaning, there is no point in looking at algorithms, right? So you should know what the meaning is. So can somebody tell me what is limit? What is the meaning of? So that means xn converges to x star, right? So in English. So limit is another way, another language, right? So limit n to infinity xn equal to x star. That's exactly like English, but in symbols. But that's not the real meaning of limit, right? So what is the real meaning of limit? No answer. Calculus. I think you would have studied this in your first pre-university, right? So first year Q, or maybe some of you might have studied this in your high school, I don't know. But what is this? What is limit? Any answers? No? Okay, so what do you mean by 1 over n going to 0? This is another symbol, right? So n goes to infinity. Well, 1 over n converges to 0, or limit n tending to infinity 1 over n equal to 0, or 1 over n converges to 0. All these things are equivalent, right? So in different languages, that's all. So what is the meaning of this? Suppose, let's look at it pictorially, okay? So if xn should converge to some x star, what do you mean by that? So you have this sequence, let's say x star is here, okay? Now what do you mean by converging to this point? It means it goes to closer and closer to x star, right? That is one way of looking at it, right? So what do you mean by going closer and closer? Well, I cannot always say that, it will go and hit x star. Not possible, right? In practice also, when you run an algorithm, there is no guarantee that it will go to the minima, right? It will go closer and closer to the minima, that's all, right? And at some point you say, okay, I'm done, I'll stop, right? So what do you mean by going closer and closer? So let's define the closeness by putting a small ball around it, okay? So I'll put a small interval around it, okay? Let me call this as epsilon of room, okay? Epsilon room, because the width is epsilon. This is epsilon room around x star. So what do you mean by xn converging to x? So if xn converges to x star, do you agree that it should enter this room? Eventually it should enter, right? And if it start entering and leaving and entering and leaving, do you think it will converge? No, right? So at least we suspect that the moment it enters, there is some stage beyond which, the moment it enters this room, it will stay there forever, right? You should be able to find a stage in the sequence. For example, if you have this sequence x1, x2, and so on, there is a stage, okay? So this is a stage. Let me call it as n epsilon, okay? That means all the sequence, for example, n epsilon, xn epsilon plus 1, and so on, all these sequence will lie in this epsilon room, okay? Right? It should stay there forever. Do you think this will guarantee convergence? Yeah, I can go and sort of oscillate within the room, right? So I can confine you into the room, but you can wander in the room, right? Randomly. So that doesn't mean that it converges to x star. So what extra condition you need? If I make this room smaller, right? For example, I make epsilon room epsilon by 2 room. I squeeze it. What happens then? Right? Now there is a stage. Well, perhaps the stage could come later, right? So maybe here, okay? This is the stage, right? stage n epsilon by 2. Okay, beyond which all the sequences that you have here will stay inside epsilon by 2 room. Is that enough? No. You want smaller room, right? Smaller and smaller and smaller rooms, right? So now, how do you define convergence, or how do you say that xn? What do you mean by xn convergent to x star? It means that you give me any epsilon room, epsilon greater than 0, any epsilon, however small or large, I can find a stage in the sequence beyond which all the numbers in that sequence beyond that stage, right, will lie inside that room, right? So there is this notion of room, right? So what do you mean by room? Can somebody tell me what is room here in this case? Yeah,
Radius of convergence.
No, I mean, what is room in this case?
The actual limiting value, how close it can go.
No, epsilon room is basically the interval, right? So that leads to the notion of interval, right? So let's look at a few notions there, right? So what do you mean by, so these are ingredients required in order to define limit, right? So our ultimate objective is to understand limit. Okay, so in order to understand limit, you need to know what is open interval and what do you mean by interval, right? Is that fine? So let's look at what is known as open interval. Okay, so what is an open interval? You look at all the numbers between two numbers, let's say a and b, but a and b should not be included, right? So an open interval I is of the form, well, I'll call it as, well, what I'm going to do is I'm going to use a notation here. So what is the notation? A comma b, right? This is an interval. It is all the points x on the real line such that a is smaller than x, but b is larger than x. Okay? But x cannot be equal to b, x cannot be equal to a, right? This is an open interval. Okay. Okay, so there are other intervals, right? So I'll not rigorously, I mean, I don't give any rigorous definition. So what about this? What is this? It's open on the left, closed on the right, right? What do you mean by that? All the numbers x greater than a, but less than or equal to b, right? So and so on. You have this, you have this. This is called closed interval because you consider all the numbers between a and b included, right? It's a closed interval. Interval is fine, right? Okay. So now let's try to define what is an epsilon room. Epsilon room is basically an interval around x star. Okay, that's an epsilon room. Okay, so now let's write the definition of limit. Okay, so convergence. Okay, this is the boring part, right? So you have to turn your intuition geometry into Greek and Latin, right? That's what we will do now. Well, it's not really boring. For many of us, it's interesting. We say that a sequence xn converges to x if you take any room, right? If for every epsilon greater than 0, okay, so epsilon is your room size, right? There exists n epsilon, right? That is your stage, right? Beyond which all the sequences will be done. There exists an epsilon such that now the sequences beyond the stage will always remain within the epsilon room. How do I write that? See, xn should be close to x, right? How close? Epsilon close. This is clear, right? Xn minus x mod is less than epsilon means what? Xn is less than x plus epsilon. Xn is greater than x minus epsilon, right? So the idea is this, right? So xn is, so x is here, right? Epsilon plus x is here, x minus epsilon is here. So in fact, this is not epsilon room, this is 2 epsilon room. That's okay, because epsilon I'll take it to be very, very small, it doesn't matter, right? So this is the picture that I have written here is equivalent to xn minus x mod less than epsilon. Is this fine? Any questions? Any questions? I've written the epsilon of room here, epsilon room here, that's all. In fact, 2 epsilon room, okay? So now I'm saying, whenever the moment I say this, I'm saying xn has entered 2 epsilon room, right? So when will this enter? And it will remain same, right? It will remain in the 2 epsilon room forever, right? So I should say that such that xn is less than this for all n, I'm sorry, I think. So for all n greater than n epsilon, right? If you take a stage beyond n epsilon, all the numbers in that sequence will remain inside this epsilon room. And remember, this is always true for every epsilon greater than 0. So you can squeeze the room and make sure that it's very, very small, however small it is. Maybe if it is small, let's say 10 power minus 10, the stage could be 100,000, beyond which everything. If it's 10 power minus 200, then it could be 100 billion power billion, whatever, right? Beyond that, everything will be then. So this is the definition of convergence, right? Any questions on this? Clear? Okay. Clear? Sure? So there are notations for this. Okay. So what are the notations? Some people say xn converges to x and going to infinity. Some people say limit n tending to infinity, xn is x, right? These are some of the standard notation, right? This is just a shorthand, right? So people cannot repeat this entire definition every time you write something about the limit. So this is just a shorthand. Okay, the inner meaning is this. Okay. So now, of course, there are certain properties, right? So what are the properties? I won't prove these things. Maybe you should try to see this, prove this. Xn converges to x, yn converges to y, implies converges to x plus y. Okay, fine. This is clear, right? If xn goes to x, what does that mean? Xn enters epsilon room, right, around x. Yn converges to y, what does that mean? It will also enter epsilon room around y, right? If you take the sum, you should enter a room around x plus y, right? I mean, it's very intuitive, but how do you prove that? Well, I will leave it as an exercise, or yeah, I will leave it as a homework problem. Okay, so alpha xn converges to alpha x for every alpha not equal to infinity. Okay, so mod alpha. You scale it, the limit should also be scaled. This is an easy proof. You can prove that pretty easily. Okay, so let's try to understand limit a little further. So what do you mean by epsilon room? So 1 over n converges to 0, right? This is something that we know. So suppose I give you epsilon. Okay, let's start with epsilon equal to 0.1. Now, can you give me a stage beyond which xn will be 0.1 close to 0? See, so this implies I want 1 by n minus 0 should be less than 1 by 10. 1 by 10 is epsilon, right? 0.1. Okay. So when will this happen? So this implies epsilon is 0.1 is 11. You take any number beyond 11, right? 1 by 11, 1 by 12, 1 by 13, 1 by 14, and so on till infinity, right? So it will always remain within 0.1 around 0, right? If you take epsilon equal to 0.001, what does that mean? 1 over n minus 0 should be less than 1 by 1000. So this implies n should be greater than 1000. That means n 0.001 is 1001, right? 1001, 1002, and so on. You take all the numbers will lie within 0.001 of 0, right? Okay, is this clear? This is what it means. This is what I mean by convergence. Clear? Okay. Yeah, because this is very important, because we will keep using that, right? So we say this is an algorithm which converges. That means you can implement that on a computer and it will stop after some time. You can stop and hope that you can be sure that you'll be closer to a good solution, right? So in order to ascertain that, we need to prove that something converges. Very, very important in algorithms.